if the question's phrased this way, are these numbers a Pythagorean triple, you're not really worried about the idea of a right triangle, so I wouldn't really draw out a diagram for this like we did in the last example. You still can. A Pythagorean triple should make a right triangle. But really, this kind of cuts to the chase. They're calling it a Pythagorean triple, which tells you right away you're using Pythagorean theorem. So it's a real big hint just in the name. The problem with this is knowing which numbers correspond to which letters. But we've said multiple times A and B don't matter. The only one that really matters is C. And how would we know which number is C? C is always the what? The biggest, the longest side of the triangle, the hypotenuse. It's the biggest number. Well, which one's the biggest number that they just gave me? Great. So I'm going to go ahead and say 13 is C, and I'll just go ahead and label it. 13 is going to be C. 5 and 12 can be A and B. It doesn't matter which one's which. The reason it doesn't matter is because I'm going to add them anyway, and the order that you add things in never makes a difference. 5 plus 2 is the same as 2 plus 5, things like that. So let's go ahead and plug these in. Instead of A, I have 5, 5 squared. Instead of B, I have 12, 12 squared. Instead of C, I have 13. 5 squared, 5 times 5, that would be 25. 12 squared, 12 times 12 would give me 144. And then 13 squared. This was in the list of square numbers we made on the very first day of this chapter. Brett? It's 169. It says here I'm supposed to add these. I want to end up with the same thing on both sides. So let's add them up. 144 plus 25 will give me 169. Are those two numbers exactly the same? You bet they are. So this one does work. So are these numbers a Pythagorean triple, yes or no? Yes. And the reason they are is because I got 169 equals 169.